What if I told you you could upload an image and have AI instantly recognize everything in it, then describe it like a human would? An app that can identify objects, concepts, and scenes, then use a powerful generative AI to create a unique description like this. In this video, I'm going to show you how I built a fully serverless AI-powered image analysis app using AWS Rekognition, Amazon Bedrock, and Terraform, all running in the cloud. By the end of this video, you'll have this fully working application, the code to build it yourself, and the knowledge to start creating your own AI-powered projects. Alright, let's dive in. Alright, before we write a single code, let's look at this blueprint, or rather this architecture diagram. Now, this architecture is fully serverless, which means no server to manage and you pay for what you use. First, the end user interact with a web front end built using HTML, CSS, and JavaScript. Now, this static website is hosted on Amazon S3. Alright. Now here the user will upload a picture, for example, a photo of a dog playing in the snow. Alright. That image will be sent through API gateway. Alright. Which is like the secure front door to our application. So here the API gateway will receive the request from the user and passes it to the backend. Next, the API gateway will trigger the Lambda function. All right. This function is written in Python. This is the brain of our operation. So in other words, this function is a small piece of code that runs only when needed. Now from here, our Lambda function first sends the image to Amazon Rekognition, which will send back a list of labels like snow, car, building, a street, or a city. Alright. Then the Lambda will take those labels, creates a prompt, and send this to Amazon Bedrock, asking it to generate a cool sentence, which is cool. Alright. And finally, the Lambda will send the labels and the new AI-generated description back to our front end for the user to see. Now, how do we deploy all this? We could click around in the AWS console for hours, but we are going to do it like the pros, with infrastructure as code using Terraform. Okay, let's dive into the code. I'm going to open the VS Code. Okay, before we begin, ensure that you have the following set up on your machine. You need your AWS account set up and activate it with administrative privileges to create the necessary resources. You need to have the AWS CLI installed, the command line interface. You need Terraform installed on your local machine. Next, this is optional. If you choose to expand this project, you need to install Python, Node.js, and NPM. All right. And last but not least, you need to set up a model access in Amazon Bedrock. Here you must have access to the foundation models you intend to use. For this project, we're going to use Titan model. Make sure that's set up. Now, if you want to know how to set up all these prerequisites, check out my previous videos and come back once you're done. All right. Now here, if I check Python, you can see I have Python installed. If I check Node is installed. If I check Terraform, I also have Terraform installed. Let's check the AWS profile, run this command. And here I have the AWS CLI installed with the necessary credentials. All right. Now here, let's organize our project files. Okay. We'll create the main directory for our project. I'll name it Image Analysis App. Inside this folder, let's create a new folder. I'll name it Terraform. Now inside the Terraform folder, we'll create some files. Let's create main.tf, all right, then variables.tf, and then outputs.tf. Next, let's create another folder. I'll name it Lambda. And inside the Lambda folder, we're going to create a new file. We'll name it imageanalyzer.python. Then we're going to create another folder. I'll name it Frontend. And inside that folder, we're going to create index.html, style.css, and finally script.js. Okay, this is our project structure. Now we'll start writing the Python code for our Lambda function. Let's open Image Analyzer Python. This function will be the brains of our operation, okay? Now, I provided a code for this entire project because I didn't want to make this video too long and waste your time. Okay. You'll find it in my GitHub repository. I'll put the link in the description below. Here we have a comprehensive step-by-step guide on how to implement this project. As you can see here, we have the diagram. And then we have step 1, the project structure. We've done that already. And then step 2 is to create the Lambda function. All right, I want you to copy this code, this one here. Copy this and paste it here. All right, if this is new to you, don't worry. All you have to do is to understand the core logic here, all right? So basically what this code does, this Lambda function takes an image, checks what's in it using AWS Rekognition, and then asks AWS Bedrock AI to describe the image in one sentence. Very simple, all right? So here we're going to import the tools we need. Here we're going to import Python libraries, JSON for working with data, both3 to use AWS services, and base64 to decode the image. And as you can see here, both3 is complaining. We have to install it to remove this error. All right, run this command. Okay, now it's done. Then here we're going to initialize AWS client. Here we set up connection so our code can use AWS Rekognition for image analysis and Bedrock for AI generated text. Okay. Then here we have the Lambda handler. This is the function that runs every time someone sends an image. And here we have body. This is to get the image from the request. Okay. So here, if there is no image, we send back an error message saying, please send an image. Okay. In this section, we have the recognition response. This uses recognition to find things in the image. All right. And here we have if not labels. Now here, if recognition doesn't find anything in the image, we will return it and we'll let the user know and suggest trying a better image. Okay. Now here, if AWS Rekognition detects an image, it's going to send a prompt to Amazon Bedrock. Then Amazon Bedrock is going to create a sentence asking for the AI to describe the image based on the labels found. All right. And then here we have the Bedrock payload. We have input text is equal to prompt. Here we tell AI how long the response should be. As you can see here, we have max token to 100. You can increase it. Next, we have to invoke the Bedrock model. Here we have the Bedrock response. All right. As you can see here, we have the model ID, which is Amazon Titan Text Express v1. Now for this project, we are using a Bedrock Titan model. If you're using a different model, you have to change this model ID. All right. And then we have the response body, which is the AI answer. All right. Here we take the AI response, clean it up, and get it ready to send it back to the user. Now, once again, to recap, this Lambda function takes an image, checks what's in it using AWS Rekognition, and then asks for AWS Bedrock AI to describe the image in one sentence. Okay. Now we are done with the Lambda function. Let's go ahead and proceed with Terraform. So here we're going to define and provision all the AWS resources needed for our backend using Terraform. Now inside the Terraform folder, first let's define some variables to make our configuration reusable. Now in the variables.cf file, paste this code. Here we're just going to define our AWS region and the project name. Okay. So here we're going to deploy all our resources inside the region US East 1. You can change it to your preferred region. And then here we have the project name, which is AI Image Analyzer. All right. Next, go to main.tf. This is the main configuration file where we'll define all our resources. Okay. So this is where we'll set up the Terraform providers, the resources, or any other modules that our infrastructure will rely on. Okay. So once again, get the code from my GitHub and paste it here. All right. So let's quickly go through it so you can understand. So the first section here, we have the provider configuration. Here we have the Terraform version 5.0, and then we have AWS as the cloud provider. All right. And here we have to set up the AWS region where we'll deploy our resources. Remember, we have this region is equal to var.aws region. This was set up in the variables file, as you can see here. In our case here is US is to 1, okay? All right, this section is where we have the IAM role and policies for our Lambda function, okay? So here we have the IAM role that Lambda can assume to get permission to do things like read images or write logs. Then we have the logging policy. So this allows the Lambda function to send logs to AWS CloudWatch so we can see what's happening when it runs, okay? Then we have the Lambda AI services policy. So this basically tells Lambda to use Rekognition to detect image labels and Bedrock to generate image descriptions. Okay, and then we have to attach some policies here. So these few lines here attach policies for logging and AI access to the Lambda execution role. All right, here we have data archive file. So basically this will zip the Lambda code from our Lambda folder so that Terraform can upload it to AWS. Okay. Here we create the function, we have image analyzer Lambda. This tells AWS to run this Lambda function and sets the timeout to 30 seconds, okay? And then we have the API gateway section. This will create the API and the endpoint. Here we are using the REST API. So this will set up our API to accept post request, okay? And then we have the API gateway integration. This will connect our API to Lambda. And then we have the core's support for browsers, okay? So this is cross-region resource sharing. So this is a browser security feature that controls how a web page on one domain can request resources from another domain, okay? So these few lines here will allow your browser to call our API, okay? Which is very essential for front-end apps. So if core support for browsers is not set properly, you might have a lot of errors, okay? And then here we have the Lambda permissions. This will give the API gateway permission to trigger the Lambda function. And then here we have the API deployment. This will deploy our API. And then here we have the S3 bucket for front-end hosting. Remember, we are hosting our application on S3, okay? Here we're going to create an S3 bucket. We'll name it front-end bucket. And this is where we'll store our front-end files. Remember, the HTML, CSS, and JavaScript, okay? And then here we have the S3 bucket website configuration. This will enable website hosting. And then here we have to allow public access, okay? So this will make the website public so anyone can access it from a browser, all right? And finally, we have the output website URL. So here, after the deployment is done, Terraform will show us a public URL for our website, and we're going to use that to visit our site and test it. So in summary, this file is going to configure AWS as the cloud provider and set the region. Then it's going to create an IAM role for the Lambda function, where we'll have the permission for CloudWatch, AWS Rekognition, and Amazon Bedrock. And then it's going to deploy our Lambda function. And then it's going to create the API gateway so users can send images to the Lambda function via the endpoint, which is /analyzer. It will add core support for browsers so that browsers can call the API safely from a web app. Then it's going to deploy the API. Then it's going to set up an S3 bucket to host our front end as a public static website. And finally, it will give us an output website URL so we can access our web app once everything is deployed. Okay, I hope that was clear. Okay, next, let's set up also the output.tf file. Okay, now here, once everything is deployed, Terraform will show us some outputs. Here we'll have the API gateway URL, the Lambda function name, the S3 bucket name, and the front-end website. Okay. Now here the next step is to create our front-end user interface. But before we do that, let's first provision and deploy all our infrastructure to the cloud, okay? So to do that, go to the terminal and then navigate to the Terraform directory. It's going to be cd Terraform. Once we're inside the Terraform folder, next we're going to initialize Terraform. Run this following command, terraform init. This will download the necessary provider plugins. Then I'll enter Terraform plan. This will show what resources Terraform will create. Okay. Okay, here we have an error. Let's see. Undeclared input variable. So here on main.tf file, we have resource AWS S3 bucket. Environment is equal to var.environment. The name environment has not been declared. Okay. So this error message is telling us our main.tf file on line 223. We are trying to use a variable named environment from var.environment. So here Terraform has looked through all our configuration files, including variables.tf, and cannot find the environment variable. Okay. So here we tagged our S3 bucket resource and we didn't mention it in the variables file. So this is the line causing the error. So what we need to do is to go to the variables.tf. So we'll add the environment variable down here. So I'll type variable environment. This will declare the input variable. And here you can see as soon as I type variable, you can see Amazon Q is suggesting a solution. By the way, you should try Amazon Q, which is a very helpful tool for developers. All right. And then here we'll have description just to explain what the variables is for. Here I'll enter, let's say, deployment environment, for example, dev, staging, and production. And then here type is equal to string, and here default will be dev. So this is the key part. It gives the variable a default value. Then I'll enter Terraform plan. Okay, it's done. And finally, I'm going to enter Terraform apply. This command will apply the configuration to create the AWS resources. Okay, here enter yes. All right, the deployment is complete. Perfect. As we mentioned in our code, here we have the output, which is the API gateway invoke URL. Now, I want you to copy this API gateway invoke URL. We're going to use it in our front-end user interface. Okay. Now navigate to your front-end folder. So here we have index.html. Again, get the code from my GitHub repository and paste it here. This is just the main HTML file for our application. Next, go to the style.css. Here is just some CSS to make the interface look nice. Then finally go to script.js. So this JavaScript file will call our API and then display the results. Okay, so here what you need to do is to replace this one here, your API gateway invoke URL. Remember the output URL from Terraform. So make sure you replace this with your actual URL you get from Terraform output. Don't use mine. Make sure you copy the one that you are seeing in your command line. Okay, and here at the end of this URL, make sure you add /analyze, which is the full URL from our API gateway. Here we have stage is v1 and then /analyze. Now, once you're done, the last step, we're going to upload these front-end files, the HTML, CSS, and JavaScript to our S3 bucket. Okay. Remember, our S3 bucket was already created by Terraform. Okay. So you can manually upload these files via the AWS Management Console, or you can use the AWS CLI. So here I'm going to use the AWS Management Console so I can upload the exact files. Okay. So go to your console and navigate to S3 bucket. As you can see here, our S3 bucket has been created. Let's click on it. And then I'm going to upload our files here. Let me go ahead and do that. Now it's done. That's the final piece that connects everything together. Now here we have to make sure that these files have public read access. All right, let's test the application, okay? Now remember, we used the S3 for hosting. So to see our website, let's click on index.html, then click on this object URL, and you should see this nice AI image analyzer interface. Perfect. Here you can see analyze image button is disabled. Now here select any image you want. You can upload a JPEG or a PNG image file from your computer. I'm gonna upload this one here. Then here you can see the button is enabled. Okay, so here's the image. Click on it. All right, here's the result. We have the AI generated description. Here it says a bird with a long beak and colorful feathers perched on a tree branch. All right, this is cool. And here we have the detected labels. We have animal, bird, finch, beak, and jay, which is exactly what we are seeing in this image. Here we have a bird with colorful feathers, with a long beak, and it's standing on a tree branch. This is cool. All right. Let's try another one. Just refresh the page. All right, let's try this image. This one has a lot of concepts, scenes, and objects. Let's see the results. All right, there it is. This is the AI generated response. This is the sentence from Bedrock. It says, this image depicts a city space with city, street, cars, and people. And we have the labels here. We have city, metropolis, we have urban, road, street, neighborhood, car, city space, person, and intersection, which is exactly what we are seeing in this image. Here we have this beautiful city with people crossing the road. We have cars, we have streets, a city space with an urban vibe. This is good. All right. And there you have it. Here we have a fully functional AI-powered image recognition and description application. This is a very interesting project. In this video, you've seen how to combine AWS AI services like Rekognition with powerful creative foundation models in Amazon Bedrock. And you've seen how to use it with a simple Lambda function and how to deploy your entire infrastructure with Terraform. Again, let's check in the AWS Management Console and see what we have provisioned. And here we have the API gateway. Remember, from our API gateway endpoint and /analyze. All right. Then here we have the Lambda function. Here's our Lambda function. And here is the S3 bucket where the application is hosted. Okay, let's clean up everything. Once you are finished with the project, you can destroy all the created AWS resources to avoid surprising costs. Okay. Now navigate to the Terraform directory and run this following command: Terraform destroy. Then yes. This will remove all the resources defined in the Terraform configuration. Of course, you can improve this project. You could adapt this to automatically tag products in an e-commerce store. You can also integrate AI-based video analysis to automatically analyze video streams in real time. Now, if you want to build this project yourself, I've put a link to my GitHub repository with all the code in the description below. Go check it out, give it a star, fork it, and make it your own. If this video helped you out, please hit that like button. It really helps the channel. And subscribe if you don't want to miss out on more tutorials on cloud, AI, and building awesome projects. I would love to see what you build. Let me know in the comment section below what ideas you have. Thanks for watching, and I'll see you in the next one.